This presentation is about technology, and I'm so happy I have here two amazing guys. One is Athila. Woohoo! Athila is from Red Hat, is my amazing colleague. And I see from the presentation you have a slight introduction about you yourself, but I will just tell he's really master in what he's doing. He is holding patent for emerging technologies. So kudos to Athila. And we have Sam, who is also known as a co-founder of Crypto Portal. So his understanding of how the NFT is created, how to promote, how to create NFTs is basically his daily bread and butter. So I would like to welcome you both in this presentation, and thank you very much for your time. So stage is yours, guys.
Well, hi everyone. Can you guys hear me well? Okay, well, my name is Athila, and is it better? All right. I did. All right, so my name is Athila. I work as an SRE for Red Hat. For those who don't know, like what SRE stands for is Site Reliability Engineering. It's a relatively new discipline into IT, introduced by Google in 2016. I've been doing reliability engineering for Red Hat for, I think, 4 years or something like that. And I'm actually here to talk a little bit about IPFS. And some of the technical implementations of IPFS, there are many of them, so not so much of like the project itself. It's actually, it means a bigger thing as we actually move into a more, let's say, modern and decentralized internet. That's basically where IPFS come into play. I'm gonna do like a very quick introduction about the project for those who don't know. I'm gonna try not to make it so technical, so boring, yeah? So we'll see. This is the agenda, like what IPFS is, the evolution of the internet, decentralized versus distributed models, apps versus dApps. Some of the use cases, the ones I think is more interesting for IPFS. And what's next, in my opinion, in my view of that technology. Not only the technology, but like how the internet's actually evolving, like it's changing. So my introduction, which I just made, I like distributed systems, high availability, and disaster recovery. These are the disciplines I like the most. I've been doing that for Red Hat, as I said. Anyway, so what is IPFS? It's basically, it actually stands for Interplanetary File System. The motto of like interplanetary is just kind of a motivation for the project developers, because they want to make this as decentralized as possible. So in the end, there's like a couple of definitions here. According to the official documentation, this is a distributed system for storing and accessing files, websites, applications, and data, right? So in the end, like this is the building blocks of a decentralized web. It's actually part of a much more sophisticated stack of technologies. So speaking about IPFS, as an individual project might not make sense if we don't understand where we're going with it, right? So this presentation actually aims to share this vision of the developers from this project with you guys, yeah, and some of the use cases which I think is important, right? So for us to understand IPFS, where it comes into play, like I put together this very brief presentation, like very brief slides about the evolution of the internet, where we came from and where we are eventually merging to, right? So Web 1.0 at that time, like from from the beginning of the internet, we had a very simple read-only kind of internet. We had only one website, static pages, nothing much, yeah? So the content creator pushed, let's say, content to the internet, and everybody else was just able to consume, like we couldn't interact with that. So it was essentially a read-only kind of internet, right? One of the most iconic things that I like the most is something called Internet Relay Chat. I know somebody who loves it in here, IRC, yeah, I do. So IRC was at that point, anyway. Then we moved into a more modernized web, which is what we have today, right? We have a kind of a client-server model, which means that we're interfacing with services that are hosted on the cloud, right? There are a lot of, let's say, attempts to mimic what the Web 3.0 is trying to achieve here, with initiatives like Kubernetes as an example, where microservices are trying to become more independent of the infrastructure where they're hosted on. and things along those lines. However, these microservices, they are not native, they were not built for the Web 3.0 because they're still talking, let's call it legacy protocols, yeah? So there's like a few definitions here. The Web 2.0 allows us to have this client, server-client architecture. We have like broadband access, everybody has access to the internet, and then we can download apps with our mobile phones, install stuff on our Linux machines, on our Macs, on our Windows, Chromebooks, whatever. But we are essentially interacting with a service that is hosted remotely into the data center, yeah? That is Amazon Cloud, Microsoft, or Azure, whatever. So they are providing us with these, let's say, services that we're consuming, right? So the SOA kind of stuff, like the web services came along into the Web 2.0, where it became a lot more of a read-write kind of internet, where we were content creators, we can push things like an Instagram story as an example, into, let's say, a shared storage which is online, right? So the Web 3.0 is a distributed, participatory, content-oriented internet, and that is the big deal. That's where the blockchain comes into play, right? There are a couple of differences or essential differences when it comes to that, because the Web 3.0 introduced concepts that were new to us up until like a couple of years ago. For example, blockchains or NFTs. Now, moving to the metaverse as an example, and let's say a content-oriented internet. So for this, like, we need a building block for us to build applications that are going to work like that, because right now we cannot expect Twitter to be hosted into a decentralized model. We cannot expect Facebook to be hosted into a decentralized model, because it just doesn't work like that. Yeah, it's incompatible because the application has been written for the web that we have today, right? Anyway, that's just a quick overview where we came from and where we're going to with that. And then I put together these slides, which is essentially how we have today versus what the Web 3 is trying to push into us. On the left-hand side, we have like a centralized model, which essentially in the middle piece, you have everything that is hosted, everything where your information is hosted. And then like the circles on the outside, these are our basically mobile phones or applications or things that we are interacting with the central piece. So the central piece into this diagram is something like Amazon Web Services as an example. Think about Amazon Web Services. They have a fleet of distributed service there running in the cloud, but they are still essentially one single piece. If Amazon.com goes down, the whole infrastructure goes down. In practice, that's not how this is exactly how it works, because we have load balancers and everything. But essentially, like, we have a single point of failure in the very last case scenario, which is at the DNS level. Yeah. Now, if we move into the decentralized model, which is on the right side of that diagram, we have something called a P2P kind of a network. Yeah, it's something like BitTorrent works. Yeah. So these things eliminate the need for having a central piece that mediates all of the communication between applications and mobile devices or whatever. So, in that perspective, I created like just an example of this simple diagram, which is the way that we interact with the applications versus the way that Web 3.0 is actually trying to push us to do, right? So again, on the left-hand side, you have a centralized model, how the traditional applications are built, yeah? We have applications built like on top of traditional systems, hosted into the cloud, which you can see there, somewhat like a data center, and you have like the cloud icon there. So every time we make a request, we are, with our mobile phones, we send the request to the ISP, which is our internet service provider, that sends it to the cloud. The cloud has intelligence. That's where the requests are processed and then they're sent back to us. Now, think about this. If I want to send money, as an example, talking blockchain here a little bit, if I want to send money to somebody, to your friend that is not necessarily hosted in the same bank, what happens is, you send a request to your ISP, the ISP sends it to your bank is eventually going to communicate to another bank, which is going to reply back to the internet service provider of your friend, and then you're going to receive that transaction in your bank account, as an example. So the technical terminology for that is called middleware. Yeah? The Web 3.0 tries to eliminate that part. As you can see on the right side, we don't have anything that is hosted as a central piece. Yeah? We have a whole bunch of It's actually depicted as a mobile phone, but it doesn't have to be. It can be a laptop, a Chromebook, just like I said, yeah? This is just easier to visualize. So, we are interacting directly with each other, yeah? As I said, on a peer-to-peer kind of fashion, right? So again, this looks great, this sounds good, but we don't have a way to do that efficiently these days. Well, we didn't have one. That's actually where IPFS comes into play. So it's important that we understand what we're trying to do here and why technologies like IPFS and a whole lot of other new stack of technology has been created for, right? So I just wanted to help this visualize so you understand more or less like how the decentralized web works, right? Anyway, some of the main features of the IPFS now. It's a very important. It provides an API for application developers to write code. That's exactly what we need, yeah? If you look back like 10 years ago, 5 years ago maybe, we didn't have a way to do that, yeah? Centralization hasn't been, well, it has been the way to do things forever because there was just no other way. We didn't have enough technology to ensure trust in the systems that were interconnected without the central piece, right? Then we have IPFS with an API, which means that me as an application developer, I can leverage that API for me to request and allocate space for me to host my application in a decentralized fashion, yeah? So all nodes that is connected eventually to a blockchain will be able to access the same data, and that is amazing for real. Because that wasn't a bait that we couldn't do that, right? So, IPFS is operating system agnostic, of course. Operating system these days, for those who knows the Brave browser, yeah? It's a whole entire operating system there, yeah? We can access IPFS nodes directly through the web browser, yeah? Just like a Chromebook. So, it's a completely like operating system agnostic protocol, yeah? It doesn't really matter what you run, you can still access the files there on a peer-to-peer base. It's distributed, scalable, and eliminates SPOF, stands for single point of failures. Yeah, we have a whole bunch of like devices connected together. Anyway, allows for offline content because it caches data, it's secure, keeps tracks of all the changes there, and so on and so on and so on. So again, what is the most important deal here? Is like before IPFS and these technology stack, we didn't have a way to develop applications, right? And this is what IPFS brings to us. Yeah, we can leverage the APIs for us to develop applications. Yeah, of course, like my favorite part is open source, and there's like a dozen of different implementations. IPFS is just not one single project. Yeah, there are, I think, like maybe more than 20, more than 30 implementations of IPFS in a different fashion. Yeah, so these are features of the IPFS. I'm trying not to make this so much technically safe a presentation, but anyway. It's just, you know, some preliminary knowledge about the how the system works. Yeah, hopefully this helps make sense. Anyway, some of the use cases for the IPFS that I put together here just for you guys to have an idea of where we're going with it. We have the education there, like it helps us to distribute content across the internet. Let's say that we have a participating or let's say a network full of computers here. One central computer can cache data and distribute it across the nodes. We don't have to fetch the same data 30 times, yeah? That is useful for example, like if we're talking far edge computing where access to broadband is expensive, yeah? That's just an example, right? We have like healthcare where, for example, hospitals, they need to retain patient data and eventually they cannot make its way into the cloud as an example. Hospitals, they don't have like the manpower to host highly skilled IT professionals, for example, to protect their systems for attacks like DDoS, as an example. Yeah? So we have like these features built into the technology, yeah, which will help and make it easier if you know what you're doing, if you have like developers onboarding that technology. So you don't have to necessarily worry about all of the security stack of, you know, hosting data. So that's just a few examples here, yeah. We had some of these examples during COVID outbreak as an example, where some hospitals were actually attacked. They suffered with denial of service attacks, for example, where they destroyed records. And so that's something that IPFS, because it distributes data and it makes it immutable, it's kind of a use case there too. Interesting ones, freedom of speech. Yeah, we had a couple of situations, for example, like in 2017 to 2020. Wikipedia was banned in Turkey as an example, so actually a bunch of activists printed the copies and they were distributing across, you know, some places of the country. And then some people basically created an offline cached data of Wikipedia through IPFS on their own hosted blockchain, and they made it available offline. Similar to the 2017 Catalan independence referendum, where they try to block that kind of stuff, but then again, activists were able to distribute the data and keep the freedom of speech just by hosting IPFS-enabled systems, yeah, where they loaded the data and they shared it freely online because you cannot regulate that. Just one more comment here. IPFS is really hard to censor, yeah? You cannot talk censorship about that. This is why I put the freedom of speech here, yeah? It's nearly impossible to censor because you don't know where your data is hosted. Of course, there is a complexity around that, right? If you're talking hundreds of thousands of, let's say, P2P nodes, it's really hard for you to know where your data is hosted. Therefore, you cannot censor it. And then we've been talking NFTs, metaverse, and Filecoin as an example, yeah? This is actually a very interesting thing because we have like right now about 10,000 of like NFT worlds that is hosted across all of the different platforms of the multiverse, yeah? We can reuse these NFTs across all these worlds because, you know, IPFS makes it available for the content to be unique, yeah? And then, of course, we have the foundation of the Filecoin, which is like a distributed network that if you want to share your free space in your computer, they're going to monetize you because that is essentially the model that you know, the Web 3.0 is bringing into play, right? Anyway, so that's basically a quick overview. What's next for me? In my opinion, the way I see it, like Web 3.0 adds complexity, yeah? It's not a simple thing to talk about. We're trying to bring application developers together so we can have them learning the APIs and understand how to write applications. And then we as users, we need to understand our role. We're talking about like removing the power from the corporation as we move into the Web 3.0. But they're going to push back, of course. There will be a way that they need to monetize that if they continue to be relevant, yeah? They've been pushing the evolution of the internet because they're making money out of our data, right? So this is a huge shift into where the industry is going, right? And we need to understand how we can either participate and be aware that we're taking back the control and they're no longer, let's say, hijacking our data and making money out of that, right? But there is a complexity around that as well. So as I said, the concepts are rather revolutionary, but as I said, it's going to take some time to take off because these technologies are very hard to regulate, yeah? They fly under the radar of the government, they fly under the radar of like all these huge corporations that are trying to kind of pin down some of that stuff. So the question really becomes, when is it going to take off? We have a lot of applications, and if we have the chance to meet again, I'm going to show you hands-on how to interact with IPFS, right? So that is not really so much technical stuff here because we do have like content identifier-based cryptography involved. For the purpose of this presentation, I just want you to understand that as we move into the Web 3.0, we need to have a way to build solid applications that we can consume APIs and therefore share, you know, a persistent and immutable storage across the nodes into the network, right? So that's all I had to say for now, and I hope I didn't make it too confusing. As I said, we're talking about like kind of a revolutionary concepts here. Web 3.0, but Web 3.0 is a very new thing, so there's a lot of like emerging technologies that we need to understand and to grasp for. Thank you.
So yeah, everything Athila said is really spot on, and it's so cool to see that we're using these decentralized file storage for NFTs and like integrating it with blockchain and everything. It's really, I think, a huge core of why we're all so excited about Web 3.0. What I'm going to show you is like what's behind an NFT, and we're going to see like how IPFS is really used and how to go from OpenSea to IPFS. So it's also, you can follow along. You can use an NFT that you like or one that's in your wallet and go to OpenSea and follow along with us. But basically, like, this is how to professionally right-click save. So it will be good use cases of it, like for using your profile picture, for different galleries, screensavers, printing,
content creation, and of course, trolling has to be there. So these are kind of like the ways to do it. You can screenshot it, you can right click save it, you can open the image in a new tab. But what we're going to see today is reading the smart contract to find the IPFS link and get right to where the creators uploaded the file. And it's usually the highest quality you can get. So this is why we call it professional right-click saving. And this is pretty much the flow of what we're going to go for, from OpenSea to Etherscan to IPFS. Yeah, professional right-click saving. This is the term that we use in the digital art gallery space for getting some of these images. Usually like the generative collections, it's harder to get in contact with the artists. Some collectors give us permission to use the pieces, so we can go around the token and get straight to the point of where it is. So, little background on myself. I'm Sam, and I'm curator at Crypto Portal. So I'm using this technology a lot for getting images and making them as high quality so they look very presentable on display. I'm also an artist at Solos, and we use IPFS metadata as the background for the NFTs. And I'll show you that in 1 second with a piece from Solos. I'm also a DJ, musician, and collector. Let's get started. So yeah, basically we're just going for the highest quality possible. So I have this piece here. This is a piece from a Solos collection by Johnny DeFeo. He's a landscape painter out of New Mexico, and he makes these plein air paintings. And so what we did is we made a generative painting collection. It's the size of a Twitter header, and cut it out different pieces and put his paintings together in new ways. So there's like background, foreground, some animals like a fox. But what we want are the details. So if you're following along on OpenSea or you have a NFT pulled up, you want to go to this details tab. And this is where we can see two really important things that we need to know. And it's the contract address and the token ID. So the contract address is where we're going to click to open Etherscan. And the token ID is just the identification number of this specific token with all of these traits and the image attached to it. So it's number 11. I can just memorize that. Sometimes you can copy it if it's too long before clicking on here, but 11's easy number to remember. So I'm going to open it up into Etherscan where we can see the contract. I'm not going to get too technical about a lot of this stuff, but we're just going to go to read the contract. So if you click contract, read contract, this is where we can start to get inside the information of what's happening in this NFT. But for today, we're not going to look at anything really. There's a lot of stuff you can do on Etherscan, actually like directly enter the contract by going to write contract, and you can connect your wallet to Etherscan and be able to directly interact with the contract. But we're going to read it, and we're just going to scroll all the way down to the bottom. And there's token URI, which is the identifier for this token. So the number is 11, as I said, and we're going to query. And this gives us the IPFS string. So this is what's so cool, and pretty much what the NFT is this string right here. As Athila was saying, like, this is a decentralized distributed file storage that's holding this information about what it is. So here we have this information, and we're going to need to like copy just the string, not the IPFS part right here. So it's just that last part. It usually starts with Q and ends with the number that you have. So it's like /11. And we can just copy this. And what we're going to want to do is make a new tab and type in ipfs.io /IPFS / this number. So we'll paste that number in. So it looks like this. We'll press go, and it will give us this. And here is the metadata. Here is exactly what is the NFT. It has all of the information we need to know. It has the name of it. It has a description. This one even doesn't have a description. It has an image. We have the external URL that leads to the website. We have other trait types like the collection, what kind of artist, who it was, and the series and which number it is. So there's lots of information we can pull from here. And this is actually what adds up to what OpenSea is searching for when you filter by traits or displaying it in certain collections. So right here, we have the image link that's embedded into this metadata. So you can see image right here. And we'll paste this up top. And this will be the direct link to our image. And right here is basically the highest quality you can get. When we go over here and we open this image in a new tab, you can see that it's generated through somewhere else. It's taking it from this Google user content. It's not taking it from directly where it was uploaded, which is in a centralized or decentralized file storage system with like the PNG and having it really like high quality where you can zoom in and see really the specific details of the piece. And this is really how we can get the highest quality. So if you want the best quality for your images, or you need to make a presentation, or you need to save it for your gallery, this is really the best way to do it. And this is the interactive hands-on. Let me see. I have a summary. See, like a little summary right here of how to do it, where you can go from OpenSea to IPFS just by following a few steps. It's like 3 to 4 steps. It gets confusing, but I think it's really helpful for using your NFTs and increasing the utility in a high quality way. As I also want to go out, I think it's really important to keep in mind what Athila said about using decentralization and like how data is stored. And, you know, like when you're building projects and you're thinking about like how to store the information, where to store it, there are lots of core concepts to keep in mind that I think resonate with Web3 technology. So that's some closing thoughts. I'd like to give thank you to Gabby and Misha and Martin and Jan for inviting me, and also shout out to Martina and shout out to Yana because I know they're there. So that's basically how you go from OpenSea to IPFS.
Are there any questions? We can have one question here, or we can search for some on Twitter or Instagram, ask him directly. Any questions? If not, then thank you.
Thank you
so much, guys.
Enjoy
Enjoy
Burnout.
Burnout.
Thank you so much.